In the 1980s, prior to the domination of the computer industry by IBM and the PC, Commodore in the United States and Acorn in the United Kingdom developed computer systems that were meant for quite serious use. And they developed their own chipsets, and in Acorn's case they used their own processor, where Commodore used the Motorola 68K series. Acorn used their own processor, and it was much faster than the Motorola processor at executing code. This gave them the ability to do more things in software. The Amiga was designed from the very beginning as a computer system with a very complex custom chipset. It was full of processors that accelerated the graphics and sound features of the computer. On the block diagrams, we can see on the Acorn side their ARM processor is massively significant and the central part of the design, whereas on the Amiga hardware reference manual you can see that the custom chip section really gets the emphasis. Acorn were obviously very proud of their processor design, and they really emphasize it, and they call out their perspective on the benefits of RISC versus CISC processors in there. When discussing the processor family that they're using, Commodore really emphasize as well the DMA capabilities of the processor, and start talking about how the DMA is used by the custom chips in conjunction with the CPU, freeing the CPU for other operations. Acorn, on the other hand, are very interested in discussing the performance of their CPU, the two models that they originally had, and of course they had many models after this, and they're really interested in discussing how many millions of instructions per second the processor can do. The Amiga custom chipset contains coprocessors that are not simply ordered to do things by the CPU, but can actually take complete control themselves. The Amiga copper processor is able to control the registers on many of the other custom chips, and although it has a very simple set of instructions that it understands, it's completely aware of where the beam is on the screen. The copper knows at any point exactly where the next part of the screen is being drawn. The copper can execute a list of instructions that essentially create a custom screen configuration for any application or game. The Acorn VidC, on the other hand, is a configurable video processor that just generates the screen from a bitmap. Both systems start with a color palette of 4096 colors, but the Acorn computers can display much deeper resolutions, having a 256 color per pixel mode. The Amiga has screen modes that can display 2, 4, 16 or 32 colors concurrently. However, the copper can be used to change which colors are being displayed on which parts of the screen. On the Amiga, the screen is organized into bit planes. These are manipulated by the custom chips to generate very fast animations. The Acorns have a screen that is displayed in a screen mode. The simpler organization of the Acorn screens is actually a lot better for software and a lot better for 3D type animations. The Amiga screen includes different layers. It has two play fields that are displayed, and on top of those it layers hardware sprites which can move over each other and which can be scrolled horizontally and vertically. The Acorn has a single hardware sprite that's used for the cursor or mouse pointer. This is actually a massive increase in efficiency compared to drawing those in software, so there is some hardware acceleration. The Amiga supports multiple hardware sprites as DMA channels. The Acorn operating system provides software functions for blitting data into the screen, and it calls these sprites. However, they are actually blitter operations. On the Amiga, these would be called bobs and would be used by the blitter to copy blocks of memory from one place to another. They're not sprites in the sense of being independent objects that move across the screen and that are generated by hardware like the mouse cursor is. The Amiga's playfields are very flexible and can be scrolled horizontally and vertically, and can be larger than the actual screen display. So this makes smooth vertical and smooth horizontally scrolling games a real possibility. The Acorn also supports hardware-assisted scrolling. It has hardware scrolling that works vertically. It has essentially two copies of the screen memory, the same memory in fact, mapped using the memory management system, because the Acorn has a memory controller and uses it to actively map physical to virtual memory, whereas the Amiga is completely missing this component. Acorn extensively use the virtual to physical memory mapping within their operating system. So for example, applications within the WIMP, the desktop system, each run at the same memory address and have their own memory allocated to them. Unfortunately, it's not used to protect the operating system, so all of these applications can still write all over the memory of everything except another application. Although the memory controller can clearly assist with smooth vertical scrolling on the Acorn systems, so vertical shoot-'em-up should be very possible, it does nothing really for horizontal scrolling. Horizontal scrolling would have to be done by moving memory around using the processor. The ARM processor has some instructions that are good at moving multiple registers into and out of memory, so it can quite quickly move quite large chunks of memory. The Amiga is able to use the hardware to smoothly scroll horizontally. With all aspects of the Amiga, the hardware provides powerful functions, but also provides some limitations. The hardware, being hardware, can only do certain things, and you have to work with it. The Amiga has independent playfields generated by the video display. These can be controlled by the copper, so the copper can set the pointers on the playfields to create horizontal scrolling left and right. On the Acorn, you have to write software routines to scroll the screen, and the processor would be very tied up with moving the memory from left to right. Sprites on the Amiga are implemented by hardware, which does mean you have to work with the hardware and with its limitations. At first it seems like there are very few sprites that can be displayed and that their colour resolution is very low. However, you can use the copper again to change the sprites that are being displayed based on the position of the screen. So this allows for many sprites to be displayed. The copper really extends the usefulness of the rest of the custom chips on the Amiga, because otherwise you'd be severely limited in the number of sprites you could display. But because the copper is able to reprogram them, including the shape and the data that they're using and where they are on the screen and what palette they're using, it really increases the flexibility of the custom chips. The Acorn sprites, on the other hand, are little chunks of screen memory which are being copied around by the processor. So there's complete and total flexibility in the number of colours they can contain and so on, and how many of them there are. However, the system will grind to a halt if you try to use too many of them, because it's having to use the processor to actually copy them into and out of memory. Really, the best you can say about the Acorn sprites are that they are a highly tuned assembly language implementation for moving data around the screen. Beyond that, there is no real sprite hardware, so the processor has to do all of the work, including restoring the background and so on. There's no real sprite priority. You're simply blitting data into the screen, and there is not even a blitter to accelerate those blitting operations to offload the processor from having to do that. So it's all heavy work for the ARM processor. You can have as many colourful sprites as you like, as long as the ARM processor is able to display them all within your frames per second. The downside on the Amiga is that you have to program that hardware correctly, and it has lots of little interesting features, like the number of colours that can be used is dependent on the number of bit planes, obviously, and the number of channels is linked to the number of bit planes, so you have to merge two sprites together to get more colours in a sprite, and even then the colours are limited that you can have. But clearly, again, the copper comes in to save the day by adjusting the palettes as necessary and by adjusting the sprites as necessary based on the position of the screen. Because Acorn have implemented a pure software sprite implementation, they can also add many more software functions to it, and they're included in the operating system, so you can scale and rotate sprites, and functions exist already written for you to do that. You have to write those on the Amiga. The Amiga hardware does not do everything for you. When these systems were contemporary, the Acorn's processor advantage really didn't succeed in overcoming the advantages of the Amiga's custom chipset. That and the fact that the Acorns weren't really in the same game market as the Amiga in the end meant that Amiga games are typically better, perhaps with the exception of some 3D games. The Acorn computers had some benefits. They had a much better potential colour depth with the 256 colour modes that they had, and it was easier to use, less complicated to write software, and it ran reasonably quickly. And you would expect that the Acorns would have been better at 3D software and possibly better at racing animations, but since most of the interesting software was actually 2D, that wasn't a huge advantage. In the long term, long after Commodore and Acorn had both ceased trading, you could say that the bet on the ARM processor paid off, because we can now run RISCOS on 2.5 GHz, 100-pound Pi 400s, and it's very, very nice. And there you do have the bandwidth for the ARM processor to do all sorts of crazy stunts. The Amiga, on the other hand, was let down by Motorola, who abandoned the processor, so it never benefited from Moore's law and never got to those 2 GHz speeds. So the Amiga community really looked into FPGA type solutions or moving on to a different architecture. So perhaps the bet paid off. The software won in the end. I'm not convinced though. I think it would have been a much better computer if Acorn had put some decent custom chips onto it, and might have been a real game changer. If you find the difference between these architectures vaguely interesting, please like and subscribe, and I'll go into some more detail on the processors and the sound system, and perhaps get some examples together.